Hello everyone! Today we will learn about Miller indices.
What is it?
Now, before going to Miller indices, let us learn about lattice plane first. So, imagine we have a layer cake, and on each layer, we have small dots like candies sitting at the edges. These dots represent lattice points, the positions of particles in the crystal structure. Now, let us think about making a slice in this cake. Imagine taking a knife and slicing through the cake at an angle. These slice that intersect layer and dots is called a lattice plane. As the knife cuts through, it will pass through some of these dots on different layer. It depends on the angle and direction of cut. So, a lattice plane is just an imaginary slice through the crystal structure that touches certain rows of particles. By changing how we slice the cake, we get different lattice planes. Here are some examples of lattice plane. In this example, the plane cut through y-axis and z-axis. Meanwhile, in this example, the plane cut through z-axis. However, in this example, the plane cut through x-axis and y-axis. Here are other examples. Now, Miller indices are a set of 3 numbers used to specify lattice plane, which write in form of HKL.
Confused about it?
Don't worry, let's learn step by step. To calculate the Miller indices of a plane, they're involved for steps. And remember, always start from origin. The first step is to identify the intercept made by the plane in x, y, and z-axis respectively. Second, take reciprocal of the fractional intercept. Third, multiply the fractional intercept with smallest denomination. Step 4. The HKL are known as Miller indices. There are some important things that need to remember. First, no need comma in separating values of Miller indices. Second, the value of Miller indices cannot be fraction. Third, always start from origin. Fourth, negative sign of plane must write as shown below. Fifth, the value of Miller indices cannot be decimal. Sixth, the value of Miller indices cannot be infinity. Now, let us learn with example. Example 1. What is the Miller indices for the following plane? Remember, always start from origin. So, let us follow the step. Step 1. Identify the intercept made by the plane, where x-axis is infinity, y-axis is 1, and z-axis is also infinity. Step 2. Take reciprocal of the fractional intercept, which is x-axis is equal to 1 over infinity, y-axis is equal to 1 over 1, and z-axis is equal to 1 over infinity. Step 3. Multiply the fractional intercept with smaller denominator, but no common denominator. So, x-axis equals 0, y-axis equal 1, and z-axis equals 0. Step for Miller indices of this plane is 0, 1, 0. Remember, no need commas in separating values of Miller indices. Example 2. Find Miller indices for the following plane. Remember, always start from origin. Step 1. Identify the intercept. Hence, x-axis equal to 2, y-axis equal to 2, z-axis also equal to 2. Step 2. Take reciprocal, where x-axis equal to 1 over 2, y-axis equal to 1 over 2, and z-axis equal to 1 over 2. Step 3. Multiply with smaller denominator, the smallest common factor is equal to. Therefore, x-axis equal to 1, y-axis equal to 1, and z-axis also equal to 1. Step 4. Miller indices of this plane is 1, 1, 1. Remember, no need commas in separating values of Miller indices. One more problem. What if the plane passes through origin?
Let's take a look.
In this case, y-intercept is 0, therefore reciprocal of y-intercept is 1 over 0, which is not possible. To solve this kind of question, you need to shift the origin to the nearest lattice point of parallel face. After shift, the new location is shown below. Now, y-intercept is -1, x-intercept is infinity, and z-intercept in infinity. Remember, negative sign of plane is written as shown. Hence, Miller indices can be represented as below.
Hope you got the concept. Thank you.